Hey ho! Hey, Mr. B here. This is 3-5. We're using the distributive property to help us simplify and solve equations. Our goal is to take something that's kind of complicated and get it back into the form that we saw before, the ax plus b equals c form. Sometimes they're not like that, but we can use our properties to get us to there. So when we look at the distributive property, we've got a few examples here. The first one is one of combining like terms, where we have these various c's involved. And this is an estate problem. I'm going to go through an example that's similar to this so we can check it out. But you can see what they did was to combine all of these it's using the distributive property. They ended up with 3.5c, or 7/2 c more accurately. And we've got the problem like we've seen before. It's in the ax plus b equals c form. If you're using the 3.5, and I recommend you don't use mixed numbers like this, better to write it as 3.5. So you don't get confused that this means 3 times 1/2 versus 3 plus 1/2, which is what that right there means. Wait, this one right here. That means 3 plus 1/2, not 3, which is 3.5. So we'll take a look at that, go through that one. Example 2, we'll be rewriting some equations. I'll be going through that with you. I have 9 y's. I take away a y. How many y's do I have left? Got 8y. Why? I don't know, because it's the question. Okay, 8y equals 40. When we're done, we substitute it back in and check it. Solving equations by removing parentheses. This is a big use of the distributive property, because we use the distributive property to multiply through something like this, even though we can't add the x and the 3. This property allows us to multiply everything in there by 2. So 2 times x is 2x. 2 times 3 is 6. Now we are into the form of the equation we've seen before. We know how to solve these. We've done it before. When you're done, you check. Remember to multiply everything in parentheses by what is outside of the parentheses and being multiplied into it. It's not uncommon for students to forget the second term. Be aware of it. Look for that kind of error as you're going through it. This last problem is another context kind of problem. What does it cost to do a rental? You're going to end up with a place where you have to clear parentheses using the distributive property. So we do that. We clear them out. We simplify it. We're now back into a form of an equation we know how to solve. We can solve it to find out what's next. I'm going to come back to guided example 5 after I've gone through some examples, and we'll pick that up at the end of this. Having done that, then you know the drill. Cover the ideas, applying the math, ask questions, discuss this, carry on with your friends. When you're ready, come and see me for your mastery quiz. Now let's get on with some additional examples. Okay, 3-5, here's our first extra example. A $350,000 estate is to be split among 4 children, 6 grandchildren, and a charity. Each child gets the same amount, while each grandchild gets 1/2 that amount. If the charity receives $35,000, how much will each child receive? Well, we need to establish some variables here, so we'll use c for child. So c is going to be our child. And grandchild is just going to be 1/2 c, right? And the charity gets a fixed amount, so not real complicated here, I don't think. Let's see. So c stands for child. 1/2 c for grandchild. Okay, so how many children are there? Each child gets 4 children, so I got c plus c plus c plus c That's the children's amount. And there are 6 grandchildren. Each of them gets a half, so 1/2 C plus 1/2 C plus 1/2 C plus 1/2 C 2, 3, 4 1/2 C plus 1/2 C. And then the charity gets 35,000. Okay, 3-5 extra examples. A 350,000 estate is to be split among 4 children, 6 grandchildren, and a charity. Each child gets the same amount, while each grandchild gets 1/2 that amount. 1/2 that amount. If the charity receives 35,000, how much will each child receive? So we know that C represents our children. The grandchildren get a half of that, so they're going to be half of C. So C is the children's amount, half of C is the grandchildren's amount, and the charity gets 35,000. So if that's true, we get C plus C plus C plus C, the 4 grandchildren, plus 1/2 C plus 1/2 C plus 1/2 C plus 1/2 C plus 1/2 C. 1, 2, 3, 4, 5. Did I get them all? 1, 2, 3, 4, 5, 6. And then the charity received 35,000, so that's just a flat amount. And that's 35,000. And the entire amount being divvied up was 350,000. Okay. 350,000. So now we can look at our doing combining like terms. The common factor here to use in the distributive property is a C. So it's C times 1, 2, 3, 4. There's 4 1C's, right? So C times that would be 4C. Plus C times 1, 2, 3, 4, 5, 6 halves. And 6 halves is pretty easy, right? That's 3. 1, 2. So 6 halves plus 35,000. Plus 35,000 equals 350,000. So C times 4 plus 6 halves. Now I want to combine these. 2 goes into 6 3 times, so, and 3 plus 4 is 7, so that would be C times 7. plus 35,000. And now we're in the form that we've solved before. We know how to solve these kinds of problems. And we could put the 7 in front, but I'm going to go ahead and we'll do that in the next line. So 7C, and I'm going to add and subtract. Plus 35,000 minus 35,000 equals 350,000 minus 35,000. What's that going to be? Looks like 315,000. And 35,000 minus 35,000 is 0. So this is going to be 315,000 will equal 7C. Now we multiply both sides by the reciprocal of the coefficient of the variable. 1 over 7 times 7C equals 315 times 1 over 7. And we get that C equals 45,000, and these are dollars. Okay, and so we got our answer. C equals 45,000, and we want to go ahead and check that. So we get that 4 children at 45,000, so 4 times 4, 5, 0, 0, 0, it's 180,000 goes to the children, plus 35,000 from the charity, and then the rest should be to the grandchildren. 6 halves times 45,000, or 3 times 45,000. And that gives us 350,000. We've checked it in context of the original problem. Okay, let's take a look at our next example here for 3-5. And in this one, we've just got a solve it. So solve 12 times y minus y equals 77. This is a distributive property kind of problem, or we could just have combined like terms. But if we look at this as 12y minus 1y equals 77. Y's are our common factor, then that means that's y times 12 minus 1 equals 77. 12 minus 1 is 11, so 11y equals 77. 1 over 11 times 11y equals 77 times 1 over 11. 11 over 11 is 1. I used the reciprocal. So y is equal to 11 goes into 77. 7 times. Got my answer. Y equals 7. We can check that real quick. 12 times 7 minus 7 equals 77. Well, 2 times 7 is 4. So 12 times 7 is 84, minus 7 is equal to 77. 84 minus 7 is 77 equals 77. It checks. So that's a quick check. We use the distributive property here just to show you that this is not kind of 12y minus y doesn't equal 12. I have 12 y's minus 1y. How many y's do I have left over is the question. We could have simply combined like terms here and said 12y minus 1y equals 11y and skipped this in between step. Okay, next up. Here we have a distributive property type of a problem, 5 times x plus 2 equals a negative 35. We want to first use the distributive property because we're stuck otherwise. So we're going to get then 5x plus 10 equals a negative 35. In our next line, we subtract 10 from both sides of the equation. Plus 10 minus 10 equals a negative 35 minus 10. 10 minus 10 is 0, so 5x equals a negative 35 minus 10 is a negative 45. There's more negatives there now. And now I'm going to use the reciprocal of 5. 1/5 times x times 5x equals a negative 45 times 1/5. And 5 over 5 is 1. Negative 45 divided by 5 is a negative 9 is our answer. Does it check? Go back over. We try 5 times a negative 9 plus 2 equals a negative 35. A negative 9 plus 2 is a negative 7. 5 times a negative 7 equals a negative 35. And indeed, 5 times a negative 7 is a negative 35, which equals negative 35. It checks. Here's our answer. Okay, that's showing your work. That's using the distributive property to solve for a problem. One more context problem to go through. So we'll take a look at that. And here we go. Company charges $99.95 per weekend to rent a truck, with the first 100 miles are free. After that, the cost is 65 cents a mile. Therefore, if the truck is driven M miles, where M is greater than 100, the total rental cost is $99.95 plus 0.65 times M minus $100. Sonia rented a truck for 1 weekend and paid $277.40. How many miles did Sonia drive? Well, we now know something here. We know that this $99.95 plus 0.65 times M minus 100 is equal to 277.40. So we know what this is equal to. We just have to isolate the variable. And first things first, let's use the distributive property and multiply it through here. So we get 99.95 plus 0.65 M times M minus 0.65 times 100. It's going to be minus 65, right? We move the decimal point 2 places because of those zeros. And that's equal to 277.40. We combine our like terms. To do that, I need to make this an addition, so plus a negative 65. And so I have 99.95 minus 65. And that's going to be 34.95. So 34.95 plus 0.65 M equals 277.40. Now I need to subtract this from both sides. So a negative 34.95 plus 34.95 plus 0.65 M equals 277.40 minus 34.95. So 0.65 M equals, does this equal 0? A negative 35 plus, yeah, that's 0. Good. And now we get 277.4. 277.4 minus 34.95 is equal to 242.45. And we now multiply by the reciprocal of 0.65, and that's 1 over 0.65, or 65 hundredths, times 0.65 m equals 242.45 times 1 over 0.65, and 0.65 divided by 0.65, that's 1, so I'm left with m, and m equals, say, 242.45 divided by 0.65 equals 373, what are we looking for, miles. 373 miles. So we've got an answer. Does it make sense? Yeah, she paid a lot more than $99.95. She drove over that distance, and so m is equal to 373. So that's our 4 extra examples regarding 3-5. I'm going to go through the guided example real quickly, just so that you have information about how to do that kind of problem, and I'll let you get on with your assignment at that time. Okay, this is 3-5 guided example. It's on page 151. Take a look at it, try to work ahead and see if you can figure out how to do it. But in this case, we've got 2 different terms in parentheses, and we have to clear those before we can carry on with it. So the first thing we want to do is we write out the equation. We're going to use the distributive property to multiply through both of these parentheses. Here, this negative is like a negative or minus 1 times 9k minus 7. So when we write that one out, we get 6k from here, plus 8, 2 times 4 is 8, minus 1 times 9k is minus 9k, minus 1 times minus 7 is plus 7. So I get 6k plus 8 minus 9k plus 7 here in that first question mark. On the next line, where we add like terms, we get that this is a negative 3k, because 6k minus 9k is negative 3k, and 7 plus 8 is 15, and that all equals 6. And then on the next line down, we start over here, and that's going to be a negative 3k still. And then the question is, what do we do to both sides? And that is subtract 15 from both sides of the equation. What do we get at that point? We got a negative 3k is equal to a negative 9, because 6 minus 15 is a negative 9. Next line, we divide each side by 3. That gives us a negative 3k divided by a negative 3. And on this side, then on the other side, it is a negative 9 divided by a negative 3. And so negative divided by a negative is a positive. And finally, we get that k equals 3. Substitute 3 for k, and does it check? So put it in there, see if it works out. Try it out. Look at covering the ideas, applying the math. See you for the mastery quiz.